Fuel system. The S-64 Echo fuel system consists of two main tanks and one auxiliary tank located in the main fuselage. The system includes an automatic shutoff for pressure refueling over the wing, refueling capability through the fuel caps, boost pumps, fuel shutoffs, a fuel crossfeed, caution lights, and a number of check valves and other features. The aircraft carries about 8,700 pounds of fuel. About 3 gallons of fuel are unusable in each tank. The number 1 engine is supplied from the forward tank, and the number 2 engine and the APP are supplied from the aft tank. The auxiliary tank transfers to either the forward and or the aft tank. There is no transfer between the main tanks. Main fuel system. The S-64 Echo has two main tanks located in the main fuselage. The forward tank is located just forward of the hoist well, and the aft tank is just aft of the hoist well. Each tank has two cells, a sump drain, a manual drain, and is open vented. Fuel boost pumps. Pumps are located in the aft cell of the forward tank and the forward cell of the aft tank. Each tank has two fuel boost pumps. The boost pumps operate on 115 volts AC from the AC primary bus and are controlled with 28 volts DC from the DC primary bus. There is a fuel management panel located at the top of the center console. It has switches for each boost pump and an indicator light which illuminates to indicate pump failure. When the switch is in the on position, the pump is producing less than 4.5 plus or minus 0.5 psi. The light will illuminate. Each pump has a check valve to prevent fuel transfer between pumps and between main tanks. A plug stat monitors fuel temperature and illuminates a fuel low temp advisory light whenever the fuel temperature is at or below 1.1 degrees Celsius. Note: the fuel temp low advisory light is on prior to takeoff. The fuel heater switches should be placed in the on position for 1 minute prior to takeoff. This will clear any ice crystals from the fuel filter which may have accumulated from water in solution in the fuel. The fuel heater should not be operated more than 1 minute in every 30 minutes. Operating the fuel heaters for each engine will not cause the fuel low temp advisory light to go out because the temperature sensing plug stats are in the winch well. Fuel quantity. Separate fuel gauging components are provided for the forward and aft fuel tanks. Each system has a fuel quantity indicator, control unit, two sensing probes in each cell, warning light, and a test switch. The capacitance sensing probes are basically a tube within a tube insulated from each other at the ends. The probes operates on 115 volts AC as determined by a ratio of fuel and air in the tank, and then is converted by a controller into a fuel quantity reading on the forward and aft fuel quantity indicators on the instrument panel. Single test and norm const switch on the fuel management panel tests both main tank systems for proper operation at the same time. The forward fuel low and the aft fuel low light capsules on the caution panel illuminate when there are 500 plus or minus 50 pounds of fuel remaining in their respective tank. The control units are on the left side of the attic above the aft seat. The auxiliary tank is the same as the forward and aft tank system, except it has no controller. Each indicator is marked from 0 to 30 in pounds times 100. Each indicator has an adjustable bug which the pilot can use to set the amount of fuel he wants in each tank. The maximum bug setting must not exceed 2,800 pounds. Should the high-level shutoff fail, the tanks may overfill and cause airframe structural damage. If the bug is set too high in the flight while transferring fuel from auxiliary to main tanks, fuel can be vented overboard. Pressure fueling and defueling valve. Located near the bottom of each tank, the valve is opened by incoming fuel pressure from the fuel truck. It is closed by back pressure from the high-level shutoff valve. High-level shutoff valve. Located near the top of each tank, it contains primary and secondary floats which cause back pressure to the pressure fueling and defueling valve, which shuts off the flow of fuel into the tank. This valve will shut off fuel flow if a signal is received from any one of the three sources: the float inside the tank on the high-level shutoff assembly, bug settings on the fuel quantity indicator gauges, pre-check switches being placed in the on position. Electrical power is not required for the operation of this valve. However, both AC and DC power must be available for the limit bugs to operate this valve and stop the fuel level at the pilot's selected limit. Note: AC power must be on during pressure refueling if the bug settings are used to limit fuel load. In the event of a high-level shutoff failure, structural damage may occur from overfueling. Low-level shutoff valve. Located in the main tanks on the pressure fuel defuel valve, it closes pressure fuel defuel valve. Defueling continues in the other tanks without air being drawn in from the empty tank, breaking suction and stopping the defueling operation. Main defuel valves. Main defuel valves used for defueling the tanks have a valve body, handle, shaft, cam assembly, clapper, spring, guide, and a snap ring. The spring between the guide and the clapper keeps the clapper closed against the valve body. The snap ring prevents the spring from pushing out of the body. The cam assembly pushes up on the clapper to open the valve when the handle that is connected to the cam assembly is turned. The valve closes when the handle is released. The handle must be held during defueling process. 4 valves are located as follows: 1 in the sump in the forward cell of the aft tank, on in the sump of the aft cell of the aft tank, 1 in the sump of the aft cell of the forward tank, and 1 in the sump of the forward cell for the forward tank. Pre-check switches, located on the left landing gear leg next to the pressure refueling nozzle. There are 4 switches in a small box with an access door. The 2 switches on the left activate the primary and secondary solenoids and the high-level shutoff valves in the main tanks to pre-test the system. The pre-test should be performed within 1 minute of being pressure refueling operations. The 2 switches are spring-loaded to off and are only for testing the system. On the right are 2 more switches for primary and secondary solenoids in the auxiliary tank. The switches may be left in the up-on position to close the high-level shutoff and auxiliary tank if no fuel is desired in that tank. The 2 auxiliary tank switches should also be placed in the up-on position within 1 minute of being pressure refueling operations. Each time the 2 left switches or the 2 right switches are placed in the up position while refueling, an abrupt stoppage of fuel flow should occur due to the high-level shutoff valves being activated. If the fuel does not stop flowing within 30 seconds, it may indicate a failure of the high-level shutoff valve. Fuel shutoff valves. Located in the attic, these valves shut off the fuel flow to each engine. The valves are controlled by fuel shutoff levers on the left and right of the engine control quadrant in the cockpit. Crossfeed valve. Located in the attic between the fuel shutoff valves, the crossfeed is controlled by a switch on the fuel management panel and uses 28 volts DC from the primary bus. It allows either or both engines to be supplied fuel from either or both main tanks. Fuel management can be accomplished by opening the crossfeed and turning off both fuel boost pumps for the tank you do not want any fuel to come from. Note: the crossfeed system should be used only during cruise flight. Auxiliary fuel system. The auxiliary or aux tank is located aft of the aft tank. It is an open-vented, single-cell tank with sump drains and manual drain. Its purpose is to provide fuel to resupply the main tanks. To do this, the auxiliary tank contains 2 boost pumps, which transfer fuel to the main tanks. The boost pumps are the same as boost pumps in the main tanks and are controlled by 2 switches on the instrument panel marked aux tank. The auxiliary fuel shutoff valve is motor operated and in the transfer pump line to make sure all fuel goes through the pressure fueling valve when pressure refueling. The valve remains in the position it was last energized. When either auxiliary boost pump switch is put in the on position, the auxiliary fuel shutoff valve and the auxiliary high-level shutoff valve receive electrical power. The auxiliary fuel shutoff valve is energized to the open position and the fuel is transferred to the main tanks. To prevent cycling through the pressure fueling valve in the auxiliary tank, the high-level shutoff valve is energized. When auxiliary boost pump switches are placed in the off position, the auxiliary fuel shutoff valve is energized closed, and the auxiliary tank high shutoff valve is de-energized. The auxiliary tank can now be pressure fueled. When either switch is on and the pumps create no pressure in the system due to the tank being empty or boost pump failing, a caution light marked aux fuel press will illuminate. The pump switches should be turned off and the light will go out. When transferring fuel to the main tanks from the aux tank, fuel flow will cease to each main tank as the preset bug limit is reached. Fuel transfer will resume automatically as soon as the main tank fuel level is below the bug setting. A fuel quantity indicator is located below the main tank indicators on the instrument panel. The aux tank has a high-level shutoff valve which operates to shut off the incoming flow of fuel when the tank is full. When ground refueling is to be done, ensure aux boost pump switches are off, as this will prevent fuel from entering the aux tank. Turning either aux pump switch on will activate the aux tank high-level shutoff valve. Ferry tank system. The ferry tanks consist of two externally mounted tanks and a control panel. The tanks are mounted at 4 hardpoints under the helicopter. Fuel is transferred to the main tanks by a transfer pump located in the ferry tanks.